So, last time I talked about Minkowski's diagram. As such, they look very simple. As I said, you have vertical axis Ct and horizontal axis x, and an event is represented by a point there. And if your space is two dimensional, if the particle can move in xy plane, then you will have x axis and y axis, and the third axis will be Ct axis. Till there you can represent in geometry, and if you have x, y, z space and time, then you have 4 dimensional geometry, which you cannot really draw lines, but you can write equations. So, this geometrical representation is extremely interesting and useful. This was published in 1908 by Minkowski. So, let me give a flavor of that, just a flavor of that, not in great detail. So, Minkowski diagrams, we call it Minkowski diagram, and in this I will mostly confine into, my space will be one dimensional x, and then we will have t. So, the diagram is like this. This is x axis and this is t axis, and we write it Ct. The value of Ct will be plotted in this direction, the value of x will be plotted in direction, and x and Ct of what? Of an event. So, in space some event has occurred, as we have talked in the whole course. Some event has occurred, and event has a location which is x, and event is occurred at a time instant which is t. So, this x and this t. So, this x and then this Ct. So, if the event occurred at somewhere at this x and at somewhere some time which corresponds to this Ct, then there is a point. So, each point on this diagram is corresponding to an event, and each event that has occurred somewhere in a space has a corresponding point on this Minkowski diagram. So, this is the first thing to learn. Now, since I will be more concentrating on Lorentz transformation and how geometrically we can represent that. So, we have x axis and we have S frame and we have S prime frame. These coordinates that I am writing are from S frame. So, this whole diagram is from S frame. So, this is the real frame, x here, y here, z here. So, this is the real frame, S frame, and then some event occurs somewhere, and you find that okay, this event occurs on the x axis at some this x, this value of x at certain time, and then for this event you have this point. But the same event can be seen from S prime frame also. The same definition, S prime moves with respect to S along common x prime axis with velocity v in positive x direction, and all those things, origins cross at t is equal to 0 and t prime equal to 0, all that same. So, this same event can also be seen from S prime frame, which is moving with velocity v as seen from this S frame, and from here if it is x t, then here the same event x prime t prime, and this x prime t prime are related to x and t through Lorentz transformation, Einstein's equations. If I try to show this x prime t prime things on this diagram, how to do that? Okay. So, let us take some special cases. The first case is event occurs at t prime equal to 0. So, the t prime coordinate, the time as seen from S prime is 0, t prime is equal to 0, and you remember t prime equal to 0 means t equal to 0 and the origins are crossing. So, origins are crossing, okay. This means your origins are crossing, your axes are just overlapping on each other at this instant t prime equal to 0. So, this is x axis, this is also x prime axis, this is your y axis, and this is also y prime axis. There are two frames here, S and S prime, and S prime is moving, okay. S prime, S is stationary, remember, two overlapping lines, this is x axis, this is also x prime axis. I am talking of t prime equal to 0, right. So, at that time origins are crossing, but then the event may occur here, the event may occur here, the event may occur here, the event may occur here. If the event occurs here, I know x is equal to 0, x prime is equal to 0, but somewhere else at the same time in S prime, remember in S prime origins are crossing here, but the event has occurred here. So, what is x prime and how do I represent that x prime in this plot? So, that is the question I am discussing in this section. Okay. So, what are our equations? X is equal to, here what we plot? We always plot x and ct, not x prime. This is a plot which is from S frame. So, what is x? X is x prime plus Vt prime divided by square root 1 minus V square by C square. And since I am considering events which occur at t prime is equal to 0, this is x prime and then divided by square root 1 minus V square by C square, that is x. And what is t? T is equal to t prime plus V x prime by C square divided by square root 1 minus V square by C square. So, this is Lorentz transform, algebraic form of Lorentz transformation. What we will be doing finally, we will have a geometrical form of Lorentz transformation. So, this, and since t prime is equal to 0, this is equal to V into x prime divided by C square and then square root of 1 minus V square by C square. So, let us multiply by C here. So, C here. So, C here and this cancels with this. So, this is equal to V by C, which is beta, V by C is beta. So, it is beta x prime divided by square root 1 minus V square by C square. Look at this equation, x equal to x prime divided by 1 minus V square by C square square root. Ct is equal to beta times, beta is V by C, beta times x prime divided by square root 1 minus V square by C square. So, what you see is Ct is beta x. Okay. So, this gives me Ct is equal to beta x, right. C times t is, this is beta, and after this beta what you have x prime divided by square root 1 minus V square by C square is just here and that is this. So, Ct is equal to beta x. There is a relation between Ct and x, and these are the coordinates of the event in S frame, and therefore, if I plot that point here, that point will be on a straight line. Remember, this is our Ct coordinate here and x here. So, and this is Ct here and x here, is just like y equal to mx, straight line y equal to mx. So, this will be a straight line. So, I can draw a straight line and this angle is let us say theta 1, let us say, let us call this theta 1, and tan theta 1 will be equal to beta, which is V by C. Okay. So, any event which occurs at t prime equal to 0 must be on this line, right. So, if you have in this x ct plot, in this plot, if I look at these points on the x axis, what is common? All these events correspond to t equal to 0 and different values of x. What is the event here? What is the time of event represented by this point? The time is 0. Suppose this point, this also represents an event. What is the time of that event? T equal to 0. So, this is x axis. On the x axis, choose any point and the corresponding event will have t equal to 0. Now, look at this. You have a straight line here. Choose any point, this, any point. they represent different events, but for all these events t prime is equal to 0. So, I will write it as x prime, this x prime line. I do not want to call it x prime axis, because x prime axis is here, this is x axis, this is x prime axis. This is fine, this is x, same x, but then this is not the axis as such. So, let me call it x prime line, but it has the same idea. On this line, for every event t prime is equal to 0, and this line is at a certain angle theta 1 from x axis, and tan theta 1 is beta, which is v by c, and this v is the velocity of this frame with respect to this frame. Now, consider events for which x prime is equal to 0. Suppose x prime, I am talking of events where x prime is 0, t prime may be anything. So, that means it is not at the time of origin crossing, it is not at the time of origin crossing. Now, t can be anything. So, this frame may be here, but this is our O prime, an event is occurring here. So, x prime is 0. So, this frame may be here at seen from S, this frame may be here, this frame may be here, this frame may be here. So, I am talking of events which occur at the origin of S prime at certain time. Those events occurs or event occurring at x prime is equal to 0. So, once again, what is x and what is Ct? So, x is equal to x prime plus Vt prime, same equation, divided by square root of 1 minus v square by c square, and that is Vt prime divided by square root 1 minus v square by c square, because x prime is 0, and t is equal to t prime plus v x prime by c square, here this one, divided by square root of 1 minus v square by c square, and since x prime is 0, this is t prime divided by square root 1 minus v square by c square, multiply by c. So, it is this. Once again, look at this equation, see what is Ct by x. This is Ct and this is x, divide by this, t prime by square root 1 minus v square by c square will get cancelled, and you will have c by v, and so Ct is equal to c by v and times x. This is 1 by beta x. Once again, it is straight line. This is your y coordinate on this plot, vertical coordinate, this plot, vertical coordinate Ct, and this is horizontal coordinate x. So, once again, y equal to mx type, y is equal to mx type, but this time the slope is 1 by beta. Now, if the angle is theta 2, angle from x axis is theta 2, what you will have is tan theta 2 is equal to 1 by beta, right. So, this is again a straight line, here, and if this angle is theta 2, this time if it is making angle theta 2, then tan theta 2 is the slope of this line, and slope of this line is 1 by beta. So, tan theta 2 is 1 by beta. What is cot theta 2? Cot of theta 2 is beta, which is tan of theta 1. So, that means tan of pi by 2 minus theta 2 is equal to tan of theta 1, right. Cot of theta 2 is tan of pi by 2 minus theta 2. So, it is this pi by 2 minus theta 2 is equal to theta 1. So, pi by 2 and minus theta 2 is equal to theta 1. So, theta 2 is pi by 2 minus theta 1. Okay. So, this theta 2 is this whole pi by 2 and minus theta 1. What does that mean? That means this angle is theta 1, right. Theta 2 is pi by 2 and minus theta 1. This whole thing is pi by 2 and minus theta 1, that is theta 2. So, this line which I am drawing now makes an angle theta, same theta 1, same theta 1 here, same theta 1 here. So, I can drop this 1, I can write just theta here and theta here, and this is tan theta. Tan theta is beta, which is V by C. Now, any point on this will represent an event for which x prime is equal to 0. And if x prime is equal to 0, what does that mean? That means it is like t axis. Suppose I am on this axis. Suppose I am on this axis. What is x here? 0. 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 So, if I collect all the points for which x is equal to 0, that is my CT axis. Now, on this line, all the points, what is x prime here? 0. 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 So, I call it CT prime line. So, every time I will not write this line, I will write this x prime and CT prime. But remember, this is not x prime axis of our frame, right, that I am not drawing here, and similarly for this CT prime. So, this is one part. If you have two frames S and S prime and you consider events for which T prime is equal to 0, those events on XCT diagram are represented by this line. And then if you consider events for which x prime is equal to 0, then the corresponding x and corresponding CT will be represented by this line on this XCT Minkowski's diagram. So, this is the one part which you have to understand, right. Now, before I go further, let me make some space. So, once again let us take a Minkowski diagram, x here, CT here, and then x prime line here and CT prime line here, right. And suppose I have a point here, and this point represents an event for which I know what is the x coordinate, where did it occur in S frame, this is my x and this is my CT. So, if I have the point here and the scales are defined, I can immediately say that where did the event occur? At this x. When did it occur? At this t. So, that is fine, that is the definition. But now I want to know, since it is on x prime line, I know that t prime is 0. For this event, this is let us call P, this point P. So, this point P represents an event, and for that event t prime is equal to 0. What is t? What is x prime? What is x prime? That is the question. Now, Lorentz transformation I can always use, and I can say that okay, x prime should be equal to x minus Vt, x is equal to x prime plus Vt prime divided by square root 1 minus beta square, V square by C square. That is my Lorentz transformation. And since t prime is equal to 0, this is x prime divided by square root of 1 minus beta square, it is this. And from this diagram, I know this theta, right, I know this theta. What is the tan theta? Tan theta is V by C. And what is this V? This V is velocity of frame S prime with respect to frame S. So, from this diagram, if this point I write O, x is equal to this OP times cos theta, right. This is right angle triangle, x is equal to OP cos theta. So, x is equal to OP cos theta. And what is cos theta? If tan theta is V by C, what is cos theta? cos theta will be V by C, this beta. So, let me write this as beta. So, this is beta by 1. So, this will be 1 divided by square root 1 plus beta square, correct, that is cos theta. Tan theta is beta. So, you can draw a right angle triangle here, this is beta, this is 1. So, tan theta is beta by 1 and therefore, this hypotenuse is square root 1 plus beta square and cos theta is 1 divided by square root 1 plus beta square. So, that is x. That means x prime divided by square root 1 minus beta square is equal to OP times OP into 1 divided by square root 1 plus beta square, and therefore, x prime is equal to, look at this, x prime is equal to OP into square root, OP into square root 1 minus beta square and divided by 1 plus beta square. So, now this is our background calculation. My final recipe is, if you have a point P on x prime line, what is the corresponding x prime? Measure this length OP on this x prime line, measure this length OP on the x prime line and multiply by this factor, 1 minus beta square divided by 1 plus beta square, square root of that thing, multiply by this factor, you get x prime. See how through this plot, through this geometry only, lengths only, I am going from S frame to S prime frame. An event has occurred, of course, I am taking a very special case here, but this will be generalized. So, there is an event for which I know what is x, what is this t, and I also know that t prime is 0. To get x prime, only thing I have to do is measure this OP and multiply by this factor. So, that is x prime. So, the scale, if you want the actual x prime coordinate, this is not x prime axis, this is x prime line. So, you go on this line fine, but the scale on this line is different. Whatever is the length here, that is measured on the same scale. This is scale and this is scale. These are same. This is length, this is length. This length scale is same, this length scale is same. But this length scale is different, right. In this S frame X CT diagram, whatever scale I am using here, that same scale I cannot use here. In the same scale I have the distance OP, but then that distance has to be multiplied by this. And similarly, if you consider events, suppose you consider events for which x prime is 0, this is my CT prime line, this is CT, this is x prime, and suppose I am here. What does it mean? It means x prime is 0. I am on this CT prime line, x prime is 0. So, for these events x prime is equal to 0, and my question is, how much is CT prime? I know this point Q, let us say this point is Q, this is O. So, on the diagram I am given a point Q. So, I know this length OQ as measured in our usual scale. From this length OQ, how do I get the time of the event in S prime frame? So, what is CT prime? So, once again you can write that same equation, T prime is equal to T plus, or T is equal to T prime plus V x prime by C square divided by square root 1 minus V square by C square, and since here x prime is 0, it is this. So, CT is equal to CT prime divided by this. So, that is from Lorentz equation, and from here this angle is theta, and if you draw a line here, this is CT, this whole thing is CT. So, CT is equal to OQ cos theta, OQ times cos theta, and cos theta is, in fact the same expressions are coming, cos theta is 1 by square root 1 plus beta square. Okay. So, CT prime this Ct prime divided by square root 1 minus beta square is equal to, right, this quantity Ct, this quantity is also Ct. So, Ct prime divided by square root 1 minus beta square is equal to OQ divided by square root 1 plus beta square. So, Ct prime is equal to same factor OQ multiplied by square root 1 minus beta square and 1 plus beta square. So, for both the lines it is the same factor which is working. So, if you are on this line, so T prime is equal to 0, what is x prime? Measure this, multiply by the factor. If you are on this line, Ct prime line, then you know that x prime is 0. What is Ct prime? You measure length along this Ct prime and then multiply by that factor. That is how you get this quantity. Actually, this can be generalized, the proof can be done easily, and if you have x here, Ct here, x prime line here and Ct prime line here, and a general point P. So, this P represent an event, a general event, some x, some t, some x prime, some t prime, and I very well know how much is x, how much is Ct. In S frame, what is the x coordinate? In S frame, what is the time? I only have to take the coordinate, drop a perpendicular here, this is x and this is Ct. But then I want to know what is x prime and what is t prime. So, what I will do? I will draw a line which is parallel to this, suppose it is here and it meets at A. This is parallel. You draw a line from P which is parallel to this x prime line and suppose it meets at A. And similarly, you will draw a line which is parallel to the Ct prime and then you get a point here which is B. O. So, to get Ct prime, measure this OA, geometrically measure this OA, multiply by this factor, and you get what is Ct prime of that event represented by P. Similarly, if you take this one OB, in this multiply this length OB by this factor and you get x prime. So, purely geometrically, if you know the coordinates x and Ct in S frame, you immediately know, doing very simple geometry, what is x prime and what is t prime. Just like in our rectangular coordinates, we draw lines parallel to the axis and then say that this is x and this is Ct. Here there are oblique axes, it is like oblique axes, and therefore you draw lines which are parallel to the two axes and see the intercepts. Here also you see the intercepts, here you also see the intercepts, and then this length multiplied by the factor gives you Ct prime, and this length multiplied by the same factor gives you x prime. So, you can go from xt to x prime t prime, the same thing which Lorentz transformation does. So, we will continue from here.